And then we have two different ways to address this problem with both the spanned and unspanned manners for putting these records. For the unspanned manner, all the records must be within one single block. It is very simple, however, it may waste lots of storage space. For example, if we will have 5 records to be placed into the blocks, we have R1, R2, R3, R4, R5. We'll put them into a sequential manner, R1, R2, we have no problem, right? However, as we are putting the R3 into block 1, we find that the space available here is not enough for us to put the whole R3 into it. If we choose the unspanned manner for storing the records into a block, then we can just ignore this block 1 and we move to block 2 instead to place this R3 into block 2, right? And then we can further place record 4 and record 5 and etc. In this way, you can see that each of the record will be within one single block, right? We can find the whole record information very easily based on starting address. We read it from here, we can read the whole R1. Reading from here, we can read the whole R2, right? Reading from here, we can read the whole R3, R4, and R5. However, the shortcoming of this manner will be we will waste this kind of storage space, right? Similar here, right? If it is not enough for the following records. And to make use of this storage space we waste here, another way we can use to replace the record will be called the spanned manner. And when the records are very large, in other words, the record size is larger than the available block size, then we can divide or partition the record into multiple parts instead. For example, if we want to store R1 to R5, R6 into these 2 blocks, we can place R1 here, R2 here. We find that this R3 is larger than the available space. However, we can divide this R3 into 2 parts, R3A, R3B. R3A can be placed into the remaining space in block 1, and R3B can be placed in the beginning of block 2 instead. And then we can further place R4, R5, R6, and R7A and etc. In this way, we can make full use of this wasted space we showed before, right? Into the spanned manner. We use this space for storing partial information of R3. It can greatly save the storage space in the disk. However, the shortcoming will be if we plan to access the full information for the records, then we probably need to go over or span over multiple blocks simultaneously. For R1, R2, it is safe, right? We just read from the beginning address. It is very easy. However, for R3, we can read from the beginning address here. However, here we find that we can only read one partial information, right, of the R3. And we may need to have some indications of the partial record pointer to the rest information of R3. In other words, at the end, we may need to have one pointer pointing to here, right? So we can know that R3 is not completed yet. We need to further read the remaining information from another block instead. And we also need to have some indication of the continuation, right? Then the question will be how can we indicate the remaining partial information and also indicate the continuation of this record which are split into multiple blocks. To address this problem, we need to introduce a sequence of the records. In other words, we have to order the records in a file by some key values. You may also wonder why. So this kind of sequence or ordering of the records allows it or make it possible to efficiently read records in order. It also allows us to do a merge join. We will discuss this later. And based on the sequence of orders, we can do it in different ways, and we have different options. Now we showed before, right? We mentioned we can divide some of the records into 2 parts, R3 here, A here, R3B here. And if we want to access the full record of R3, we have to read both this part and this part, right? Then how can we do this kind of readings? Then how can we indicate we have some partial information and we indicate this continuation of the information for R3? We have 2 options. The first option is to physically allocate the space of these 2 blocks just nearby to each other. Alright, if we have block 1 and block 2 is just next to block 1, in this way, this R3A and R3B is just next to each other, right? Even though logically they are divided into 2 blocks, however, physically they are still storing in the same or in a continuous storage space. If so, then we can just read the full record information continuously, right? Because they are stored physically continuous to each other. This is one way we can do this. Another way that if the blocks they are actually stored in 2 different location or they're not continuous to each other. If so, then we can add one pointer pointing to the next starting address of R3B here, right? In other words, after R3A, this part we can add one pointer pointing to R3B in this manner. Now here we have R1, right? R1 is just one part, and then we can add one pointer pointing to the next R1, right? If we have further next R1 here, then we can add one more pointer pointing to the next part, right? In this way, we can link them together, and via these pointers, we will be able to access the full record of R1 as well. So this is another option we can use to read the full record if they exceed the size of the blocks, and we can still be able to read the full record successfully, even though they are stored in different blocks. Okay, so I hope you can follow me, right, for storage in this kind of data into DBMS. I think that's generally for it for this week, and we'll continue to talk about the data storage and representation in the next week, and we will be able to finish this section with one more class. So you can also go over the slides by yourself during the weekend.